Hi everyone, so welcome to the final lecture of EMFT. After this, the EMFT series will end and we have seen every single thing that is required for our examination. Now we are seeing the miscellaneous concepts. Now in this video, we are going to see two concepts. First one is the total internal reflection, which we have already studied, but now we are going to study total internal reflection with respect to wave phenomena. And then we will study polarization at media interface. Okay, so these two topics we are going to see, and in that we will see what we need to learn. So those are very important as per me, because if they want to frame a new question from EM wave, then these are the topics they can frame the questions from. So those are very important as according to me, right? And one more thing I want to tell, like if you are watching this video, this is the final video, I need your full concentration, because those are very intuitive concept and important as well, and also those require higher concentration. If you are not concentrated enough, then you will not be able to understand. So from here we need to start total internal reflection using wave phenomena. But let's do a revision question. So what we need to write down? Here we need to write down E field expression. So have we seen this kind of wave? The wave is traveling in zx direction. It is traveling in z direction as well. It is traveling in x direction as well. And electric field is in y direction. So we need to write down the wave equation. Have we seen this question? Yeah, ditto same question we have seen. Where? Wave propagation in arbitrary direction. So our first video of oblique incidence, there we saw this concept. Say yes or no. So what we need to write down? We need to write down the E field expression. So how will I write down? This is my E field. If this electric field can have any amplitude, I am assuming that amplitude is E naught. Where is this electric field? Electric field is dancing in y direction. How do I know that? Because z cross x will give me y. So y is here. This is my y. So z cross x will give me y. So my electric field is dancing in y direction. And here what I will write? E to the power minus j beta z. But instead of beta z, what I will write? K dot r. What is my k vector? K is known as propagation vector. How do I write propagation vector? Beta into what? The direction of wave propagation. So wave is propagating in z direction and x direction. So what I will do? I will assume this vector having a length of 1. So this is having a component of cos 60 degree in z direction and cos 30 degree in x direction. Or you can say sin 60 degree in x direction. So in z direction, how much component you are having? Cos 60 degree. And in x direction, how much component you are having? Sin 60 in x direction, right? So what you are getting? Beta cos 60. We are doing it a bit fastly because we have already studied it. It is just a revision question. Plus a sin 60. So it was AZ cap. Say yes or no, right? And if I need to find k dot r, then what that would be? So that would be beta z by 2 plus under root 3 by 2 beta x. So what I am going to write here? E naught e to the power minus j beta z by 2 plus under root 3 by 2 beta x plus ay cap, right? 60 degree component, that would be 1 by 2, and 30 degree component, cos 30 you can say, or sin 60 also you can say, that would be under root 3 by 2. So this is how we will write down. So this is in one step only you could have written it down. Same goes for this one. Can you write down for this one as well? So in one step only I am going to write down now. They have given theta. This time they have given theta. Okay. So how will I break it down? In two components I will break it down. That my electric field is in y direction only. Again it is in y direction only. But here there are two components. Two components of my traveling wave. So my wave is traveling in minus z and plus x. My wave is traveling in minus z and plus x. So my electric field will be E naught. It is in y direction. E to the power minus k dot r. Let's write down k dot r as of now. So what will be my k vector? So magnitude is beta. Now what I will do? I will assume the length to be 1. So in minus z direction, how much component you are having? Cos theta component you are having in minus z direction. So cos theta minus az. Are you getting this point? Minus az, the minus is going here. Cos theta minus az plus sin theta. In x direction you are having sin theta component, ax cap. Say yes or no. Are you getting this point? Cos theta in minus az, sin theta in plus ax. So what will be your k dot r? So my k dot r will be minus beta cos x cos theta z plus beta sin theta x into x. into x into z. So if I need to write down my E field expression, what that would be? E naught e to the power minus j here minus beta z cos theta plus beta x sin theta ay cap. No need to mug up anything. I'm just asking you that can you write down these expressions? You should have the good habit of writing down these expressions, right? Let's move on to our concept now. What we need to study? We need to study total internal reflection. So let's understand it using a question. Okay, we will solve a question and that will be very, very intuitive. You will learn a lot of new things here. So this is a medium 1, this is a medium 2. A wave is incident on this particular boundary. What is this boundary? This boundary is xy plane. So wave is incident on xy plane. Are you able to understand? Where will be my y? My y will be coming towards me. We have already seen oblique incidence. So we are not going to spend time on oblique incidence. We are not understanding oblique incidence here. XY plane is there, wave is striking like this. Now what will happen? The wave will be reflected back. Some part of the wave will be reflected back and some part will be transmitted. Right? Now you just let me know one thing. This is your denser medium. This is your rarer medium. You are going from denser to rarer. So what will happen? Wave will move away from the normal. So what is the normal? This is the normal. So wave will move away from the normal. So this is how the wave will move. Although this is not important as per your question, but just I am writing it. So this will be your theta t. This will be your theta r. And theta r would be equal to theta I only. All these things we already know. And this is my incident electric field. My electric field is in y direction. So which kind of case it is? This is a case of perpendicular polarization. Perpendicular polarization. You need to have a good knowledge of oblique incidence, then only you will be able to understand it. Otherwise you will not be able to understand. So this is the case of perpendicular polarization. Now what all question we are asking? The first question is you need to take omega equals to 3 into 10 to the power 8 radian. The first question is you need to find the value of critical angle. So can you write down the value of critical angle? Certainly I can write down the value of critical angle. What is that? Critical angle is, in the last lecture we have studied it, right? Critical angle is under root epsilon r2 divided by under root epsilon r1. So under root epsilon r2, that is under root 1 only, divided by under root epsilon r1. So what you are getting? This is roughly around 20 degree as far as I remember. But let me calculate again. Yeah, 20.70. 20.70. Now what is the question B is saying? If theta I is 30 degree, then comment on the waves in medium 1 and medium 2. So now till this knowledge, whatever the knowledge that you are having, based on that what you will say? That sir theta I is equals to 30 degree. So here theta I is greater than theta C. That means this is the case of total internal reflection. And if this is the case of total internal reflection, that means in medium 2 there should be no wave. This is what you will say. If this is the case of total internal reflection, that means whatever the wave came, that will be reflected back. So in medium 2 there will be no wave. This is what you will be saying, but that is not correct. Let's check that out, what we need to do now. Okay, so this is our question now. This is why we are studying this concept, that in medium 2 as well there will be some wave. What will be the nature of that wave? What will be the nature of the wave in medium 1? That we need to check out. Okay, so what first I will find out? I will first find out the value of theta t. What I will find out? I will first find out the value of theta t, because if I need to write down the wave equation, in medium 1 and medium 2, I need the value of theta t, right? So first let's find out the value of theta t. So what I am going to apply? I am going to apply Snell's law. So as per the Snell's law, what I will do? Under root epsilon r1 sin theta I is equals to under root epsilon r2 sin theta t, under root 8 sin 30 is equals to sin theta t. What is sin 30? 1 by 2. And this is 2 root 2. What is this? Under root 8 is 2 root 2. And sin 30 is 1 by 2. So what you are getting? Sin theta t is under root 2. So from here, what do you understand? There is no practical theta t possible like that, right? Because sin theta t can be from -1 to 1 only. But this is coming out to be under root 2. So no practical theta t is possible like this. This is what we are getting from here. But let's do something. Let's first write down the value of cos theta t here. What will be my cos theta t? Why I am writing it down? Because I will be requiring the value of cos theta t in reflection coefficient. If you remember the formula of reflection coefficient, if you remember the formula of transmission coefficient for perpendicular polarization, then certainly you know that there cos theta t will be required. So that I am writing down. So what will be my cos theta t? Cos theta t will be plus minus under root 1 minus sine square theta t. Do you agree to this point? Say yes or no. You agree to this point, right? Plus minus under root 1 minus root 2 square. And here you will get it to be, what is root 2 square? That is 2. 1 minus 2, that would be minus 1. So under root minus 1 is, basically this is under root minus 1. Say yes or no. And that is j. So from here what we are getting, cos theta t is equals to plus minus j. Say yes or no. You are agreeing to this point? Now, secondly, one doubt you will be having, that sir, why this plus minus? When we were studying oblique incidence, you never used this plus minus. Because in oblique incidence, when we were studying oblique incidence, I knew that my theta t would be from 0 to 90 degree only. Say yes or no. This angle can be there from 0 to 90 degree only. And between 0 to 90 degree, cos is always positive. Cos is always positive between 0 to 90 degree. This is the graph of cos. So between 0 to 90 degree, cos is always positive. So at that time, I never used plus minus because I knew that my cos will be positive only. So here I used positive sign only. Although there as well I should have put plus minus, but I knew that always it will be positive. So that's why I did not use it. But now this theta t is not practical. This theta is not practically possible because cos theta t can never be equal to plus minus j. So that's why I need to use plus minus sign here. So cos theta t is equal to plus minus j, right? Now what I'm going to find? I'm going to find the reflection coefficient first. Reflection coefficient for perpendicular polarization. And whatever the formula that we remember, that is for electric field. If you remember it clearly, the formula is for electric field. So what is the formula? Neta 2 cos theta I minus neta 1 cos theta t divided by neta 2. I also told you the trick as well. Since it is perpendicular, that means two are cutting each other. So neta of this one, theta of this one. This is how I have told that trick as well. Plus neta 1 cos theta t. What is your cos theta I? Cos theta I is cos 30. That is, incident angle is 30 degree only, no? Incident angle is 30 degree we are taking. So cos 30, that is under root 3 by 2. Right? What is your neta 2? Neta 2 will be 120 pi, and here epsilon r is 1 only. For the second medium, epsilon r is 1 only. So 120 pi, only 120 pi, because epsilon r means the second medium is air. So this will be your neta 2. What will be your neta 1? Neta 1 will be 120 pi under root epsilon r1. What is epsilon r1? That is 1 by under root 8. Say yes or no. Do you agree to this point? And what is your cos theta t? That is plus minus j. So let's write down all the values. Here I will write down 120 pi, here also 120 pi, here also 120 pi will come, and here also 120 pi will come. So 120 pi and 120 pi will get cancelled. So that 120 pi I am ignoring. So what I am going to write down here, what is neta 2? That will be my 1 only. 120 pi is cut. So here neta 2 I am taking as 1. What is cos theta I? That is under root 3 by 2. Minus, what is neta 1? 1 by under root 8 I am writing. Why I am writing 1 by under root 8? Because 120 pi is getting cancelled. And what is your cos theta t? That is plus minus j. Plus minus j. Divided by same thing, under root 3 by 2 plus 1 by under root 8 plus minus j. So when you solve it, what you are getting? Reflection coefficient. So here I can solve it. Okay, first just the mathematics we are solving it. So here under root 8 can also be written as 2 under root 2. Under root 8 can be written as 2 under root 2. 2 under root 2, right? So this 2 and 2 is also getting cancelled. And from here what I can get is that some mistake I am doing here. Cos theta I. Neta 2 is 1 by under root 8. Wait a second. Yeah, so I checked the calculation. Calculation is going fine only. So what do we get if we calculate the reflection coefficient? So we are getting, you can do the calculation on your own. So let me show it. So this 2 and 2 will get cancelled. Here we are having minus plus j by under root 2. How did I write minus plus? Because already there is minus. So minus is multiplied with plus minus. So minus is multiplied with plus, it will make minus. Minus is multiplied with minus, it will make plus. So that's why I am writing minus plus, right? And divided by the same thing, under root 3 plus minus j by under root 2. Why plus minus? Because here there is plus in between, right? Now the scene is, first time you need to take minus plus, and then you need to, basically if I take minus upper side, then downward I need to take plus. If I take plus upper side, then downward I need to take minus. From here we can get two kind of reflection coefficient, no? So if you take minus upper side, then downward you need to take plus. So basically this will be the scene. Okay, upper side I am taking plus, so downward I need to take minus now. And if I upper side, if I am taking minus, then downward I need to take plus, right? So if you solve this one, what you are getting? If you solve this one, so one thing you already know, that magnitude will be 1 only. This is simply a plus j beta divided by a minus j beta. So what will be the magnitude? Magnitude will be 1. There will be some angle, so that angle I have already calculated. You can also calculate. So here magnitude will be 1 and the angle will be 44.41. Here the angle will be positive. This you can directly see, because this will be in first quadrant and this will be in fourth quadrant. So that will come and it will be, so this will be 44.41. This will be positive and this will be negative. So resultantly, can you write down your reflection coefficient as magnitude is 1 e to the power j plus minus 44.41. Say yes or no. This is my reflection coefficient. Now based on this, first you let me know what is your expression of incident electric field. First write down the expression of incident electric field. So my incident electric field is in y direction, right? But now I need to write down my wave, how my wave is going, because I need to write down the factor of k dot r. What do I need? I need k dot r. So my wave is going like this. How much angle is this one? Since this is theta I, so this will also be theta I. So this angle will be 30 degree. This is how my wave is going. What amplitude I will assume? 1. So cos 30, what is cos 30? Under root 3 by 2 in z direction, and sin 30, that is 1 by 2 in x direction. Do you agree to this point? 1 by 2 in x direction. So wave is propagating in plus z and plus x. So under root 3 by 2 in z direction and 1 by 2 in x direction. Say yes or no. So this is your k dot r. So from here ki dot r cap I can write down. Ki dot r I can write down. What is that? Ki dot r, that is under root 3 by 2 z plus 1 by 2 x. So this is just the wave equation I am writing down. Now I can write down my wave equation. So what will be my wave equation? Electric field is in y direction. So e to the power minus j. Here the wave is going in under root 3 by 2 z plus 1 by 2 x. And electric field in y direction. Can you write down the reflected electric field now? Certainly I can write down. But for reflected electric field, my components will change here. Which components will change? Here my field will be in my reflected electric field. I don't care about my reflected electric field direction. What I care about my reflected EM wave direction. So this is my reflected EM wave direction. So my reflected EM wave is going into minus z and plus x. So here if I write down my reflected electric field, so what that would be? Reflection coefficient into E naught e to the power minus j. This is going in minus z. So here minus z. All these things we have already studied. That's why I am being very fast here. Otherwise I have explained these points in a very detailed manner, right? So direction of electric field will be taken care by this reflection coefficient. Although we already know that if this reflection coefficient is becoming positive, that means direction of electric field did not got change. But if it is becoming negative, that means direction of electric field is getting changed. But here it is complex. So we cannot conclude anything as of now. So what I can write down? So here what I am getting? So this has a magnitude 1, but this has a phase. So that phase is plus minus j 44.41 e to the power minus j. Just this direction is changed. That's it. So this is my reflected electric field. Now if I find a total field in medium 1, what I am finding? Total field in medium 1. In medium 1. Look, why we are doing all these calculations, you will certainly get to know. Okay, very interesting conclusion will come out of it. So just watch on to the video. Total field in medium 1. Total field in medium 1. So what that would be? Here there is two kind of fields, incident and reflected. So let's write down the incident field. E naught e to the power minus j under root 3 by 2 z plus 1 by 2 x ay cap plus E naught e to the power, there is some phase 44.41 e to the power minus j e to the power minus j. This will be negative and this will be positive only. So can I take out something common? Can I take out something common? That will be e to the power minus j 1 by under root 2 x ay cap. Because here as well e to the power minus j 1 by 2 under root x is there, not under root 2, really sorry, 1 by j 1 by 2x. Here as well e to the power minus j 1 by 2x is there. Here also e to the power minus j 1 by 2x is there. Inside what I will get? E to the power minus j under root 3 by 2z, right? Plus here there is a phase factor plus minus j 44.41 plus e to the power j under root 3 by 2 z. Is this what you are getting? Say yes or no. This is the expression you are getting. Now what you can see here, what is this and what is this? This is your traveling wave in x direction. E to the power minus j beta z is written. What does that mean? Traveling wave in z direction. E to the power minus j 1 by 2 x is written. What does that mean? Traveling wave in x direction. And what do you think? What is this? Think about it again. What is this? This is your standing wave, no? This is the incident wave. This wave is traveling in plus z direction. And this wave is traveling in minus z direction. Both combined, what they will make? Standing wave. So what is this? This is your standing wave. So when on a plane my wave came like this, then what happened? There was a reflection. Now if I combine both of the electric field, which is incident electric field as well and reflected electric field as well, or I can say if I combine both of the waves, incident wave and reflected wave, then when I combine them, I get to know that there is a standing wave as well and there is a traveling wave as well. So what kind of field pattern I will get in medium 1? So let's make the field pattern of medium 1. So what kind of field pattern I will get? I don't know where will be maxima, where will be minima, all will depend on this factor, because you know how to find the maxima and minima. You will take this outward, then you will put it equals to 2n pi, 2n plus 1 pi. So that process you already know. One thing I am sure that at z equals to 0, I am not gonna get minima or maxima. See, this is my z equals to 0, and till this point I am going towards z equals to minus infinity. So what I am getting here is that here what I will get maxima or minima, that will depend on these factors that I don't care about. But one thing I am sure that I am getting a standing wave pattern like this in z direction, standing wave in z direction. I am getting a standing wave in z direction, something like this. And now this standing wave is traveling in plus x direction. Say yes or no. This is your plus x. Is this clear to you or not? There was a boundary, incident wave came, it was incident like this, and then it was reflected back. When I both combined, I got to know that I am having a standing wave in the z direction, and that standing wave is traveling towards x. So this kind of pattern you are getting in medium 1. And this is not only for the case of a total internal reflection, this is for any single case. Every case, this will work for any single case. Because here what we are getting, here we are getting this factor. If there was no total internal reflection, what I am saying, if there was no total internal reflection, then what would have been your electric field? Your electric field would have been something like this: E naught e to the power minus j, then this factor, ay cap, plus E naught, and then here gamma perpendicular would come, and that would be a real quantity. Let's just say that quantity is 0.5, and then e to the power minus j, this factor. So same, everything would be same, just in place of this, you will have a real quantity, that would be 0.5, something like that. So again, this would be the standing wave in z direction. Again, this would be traveling wave in x direction. So whether it is a what do we say? Whether it is a normal reflection or it is a total internal reflection. In both of the cases, what you are getting in the direction of z, you are getting your standing wave, and that standing wave is traveling in x direction. And now try thinking about it, why this is happening. Okay, I am giving you an intuition. Do you remember the normal incidence case? Do you remember the normal incidence case? In normal incidence, what was happening? That a wave came like this, and then it was reflected back. And when we combined both of them, what we were getting? We were getting standing wave. Do you remember this or not? There was no traveling wave. In case of normal incidence, we have seen the concept of traveling wave. A wave came, it was reflected back. When we combined both of them, it was a standing wave. There was no traveling wave. Only standing wave was there. I showed you the animation as well. That this standing wave was dancing like this. This point was coming up, coming down, coming up, coming down, coming up, coming down. In that manner, it was dancing. Say yes or no? Right? So, in case of normal incidence, there was no traveling wave. But in case of oblique incidence, there is a traveling wave. Why this is happening? Let's try thinking about it. So, how my wave came? How my wave came? This is how my wave came. And this is how it got reflected back, right? Now, this is having a component in this direction. 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 The component in x direction, this I assumed as x direction, this I assumed as z direction. The component in x direction are getting added. So that means this wave was traveling in x direction. Now this wave is also traveling in x direction. Both got added, and what happened? They were traveling in x direction only. Are you getting this point or not? Both of the component here, this component and this component, both x direction component added. And if a component is being added, let's just say I am working in x direction and you are also working in x direction. If I combine both of the work, that means we are resultantly working in x direction only. But here what is happening in z direction? One wave is like this, another wave is like this. And in case of normal incidence, what was the case? One wave was like this, another wave was like this. And when both combined, what did it make? Standing wave. Here also, one wave is like this, another wave is like this. Both combined, what it will make? Standing wave. So in z direction, you are getting a standing wave, but in x direction, you are getting a traveling wave. So in the examination, if these kind of questions are coming, they will give you random values. Here one correction. Here I will not get maximum or minima, no? So I should have made it like this. Okay, because at z equals to 0, I will neither get maxima nor minima. Some middle value I will get, so that value I am showing it. So in the examination, if this kind of question is coming and they ask you what kind of field pattern you will get, so you will just make this a diagram. You will just make this diagram, and you will see that what all are the opposite waves. So these opposite waves combined will make a standing wave. But those which are traveling in same direction, they will make a traveling wave. That's it. In EMFT, opposite waves traveling together makes a standing wave. But the waves which are traveling in the same direction, they will make that. What they will make? They will make a traveling wave, right? If I ask you another question here, just a small question I want to ask. Let's just say this is my boundary, and this is how my incident wave is coming, and this is how my reflected wave will be. Now tell me in which direction you will get the standing wave, and in which direction you will get the traveling wave. Okay, this is how my wave is coming. This is my media interface, and this is how it is reflected back. So in which direction you will get the traveling wave, and in which direction you will get the standing wave? This is my question. So what you will do? This has two components like this, and this has two components like this. So these are being added. That means this will be the traveling wave, and in this direction, this and this. So in this direction you will get the standing wave. If I call this direction as, let's just say this was your x, and this is your z. So now in the z direction you will get the traveling wave, but in x direction you will get the standing wave. Is that clear to you? A very important, a very good concept which can be asked in 1 mark question. Okay, so medium 1, that is that is independent of any total internal reflection. I am telling this case for any general case, because here you could have any 0.5 value as well, 0.6, 0.3, 0.2, anything it could be. So it could be any case, whether it is total internal reflection or our ordinary kind of reflection that we have already studied. In both of the cases, you will get standing wave in medium 1. Also, you will get a traveling wave. Now, now if I ask you, what is the velocity of this wave? What is the velocity of this wave? So what will be your answer? Look, if you don't know any concept, and if I ask you, what will be the velocity of wave in this medium? What you will do? Sir, velocity of wave will be Vp equals to omega by beta. So what is omega? 3 into, or you can, what you will write down? Sir, what is beta? Beta is, sir, omega by c under root epsilon r. Omega by c under root epsilon r. So sir, this and this will get cancelled. So your VP would be C is 3 into 10 to the power 8 and here epsilon r is under root 8. So this will be your VP. So this is the velocity in medium 1. This is what you will be saying. Wrong. Why it is wrong? Let's check that out. So this kind of question can be coming in your examination. This is what I expect. They will say that this is how the wave is incident. This is how it is reflected. They will ask you the reflection. They will ask you this expression they can ask. Which expression? This expression they can ask. And then they will ask you what is the velocity of the wave. Then velocity of the wave, everyone will apply C upon under root epsilon r. This is wrong. Why is that so? Because wave is traveling only in x direction. Wave is traveling only in x direction. It is not even traveling in z direction. So why you are taking the beta of x direction and z direction combined? You only need to take the beta of x direction only. And what is the beta of x direction? That is 1 by 2. What is the beta of z direction? The beta of z direction is this under root 3 by 2. Here I forgot the value beta. Here I forgot to write down beta. Sorry. Here I forgot to write down beta. Everywhere I forgot beta. Sorry. Here beta should have come. Everywhere beta should have come. Right? I forgot beta here. Although beta value is 1 in this case. I have set my expression in a manner that beta value is 1 only. So everywhere beta should have come. That is my mistake. But when I was writing C upon under root epsilon r and when I was putting the value of under root epsilon r, from where this formula came? This formula came from Vp equals to omega by beta. So what is my beta? What is my omega given? 3 into 10 to the power 8. And what will be my beta? When I am writing 2 under root 2, that means I am taking this guy as well and this guy as well. And that is wrong. Because my wave is only traveling in x direction. It is not even traveling in z direction. If I ask you what is the velocity of the incident wave, what I am saying, velocity of the incident wave, velocity of incident wave. So in the incident wave, there are both of the components, that is z as well and x as well. So the incident wave is traveling in z direction as well and x direction as well. So I can say that my incident wave is traveling in x z direction. There will be no harm in saying so. This is absolutely correct. XZ direction. So you will take beta of x as well and beta of y as well. What I mean to say is that your beta will be beta x square plus beta z square. So both betas you will take. So what will be your VP now? Your VP now can be C upon under root epsilon r. Now I am happy with this. Or you can write down omega upon beta. Omega upon beta. Omega upon beta. So that is 3 into under root 8 omega is given. And what will be your beta? Beta is omega by C under root epsilon r. What is omega? 3 into 10 to the power 8. What is C? 3 into 10 to the power 8. And what is under root epsilon r? So here both will come. So here you can write down. So this will be the answer. So here your beta is under root 8. And if I ask you what is the velocity of a reflected wave? Velocity of reflected wave. So that will also be same because reflected wave is also traveling in xz direction. Reflected wave is traveling in xz direction. So what will be the velocity? Velocity will be the same thing, 3 into 10 to the power 8 divided by under root 8 meter per second. Now if I ask you the velocity of total wave, in medium 1, then what will be your answer? Velocity of total wave in medium 1. Then what will be your answer? Your answer will be only here wave is traveling, total wave is traveling only in x direction. In x direction. So what will be your VP here? That would be omega, that is 3 into 10 to the power 8 divided by beta. So beta of x only I need to take now. So what is my beta of x here? Beta of x, that is beta into 1 by 2. Beta of x is beta into 1 by 2. And what is my beta? Beta is under root 8. So under root 8 into 1 by 2. That will be under root 2. So here my beta will be under root 2. So what will be the answer? The answer will be 3 into 10 to the power 8 divided by under root 2 meter per second. So this will be the answer. Are you getting this point or not? Why this is the answer? Are you understanding this point? So here we have taken beta of, let's remove it off. Here we have taken the beta of z as well and beta of x as well. If I take both of the betas, then what I'm here under root will also come, sorry. So if I take both of the beta, then here what will happen? Beta of z direction is under root 3 by 2 beta. Under root 3 by 2 beta whole square plus 1 by 2 beta whole square. If you calculate it, what you are getting? 3 by 4 plus 1 by 4. That would be 1. So what you are getting? Beta only. So here your complete beta is equals to beta only, and that beta is under root epsilon r, under root 8. But here your beta is equals to, here my beta is equals to beta x. Here my beta total is equals to beta x, because my wave is only traveling in x direction. Very good point. This kind of question I can expect from EMFT in future, where you need to use your brain. So you will just, first you will find in which direction, if they are only asking you the velocity. So what you will find? First you will find in which direction my wave is traveling. So I got to know that my wave is traveling in x direction. So I will take beta of only x direction. I will have my incident field expression. I will write down my E field expression. Then I will get to know that in x direction how much beta I am having. Because if I have written down my E field expression, so here I can get to know that this is my beta. My beta is beta into 1 by 2. So total beta, whatever that was there, that is under root epsilon r divided by 2. So this will be my total beta. Are you getting this point? Or kind of you can write down it is beta sine theta I. Say yes or no. Why it is beta sine theta I? Because if this is the direction of your k, then this is the k vector in x direction, and this is the k vector in, sorry, this is the k vector in z direction. This is the k vector in z direction, and this is the k vector in x direction. So I only need to take the k vector in x direction, because k vector in x direction will have a magnitude of beta x. So from here only I would get to know, first I will calculate my beta, that would be omega by c and root epsilon r. When I apply this formula, after applying this formula, what I will do, I will see that this is the total beta, but my wave is traveling only in x direction. So for x direction, what I need to take, this is theta I, so I need to take sine theta I component. That's it. This will be my beta. This is how I will solve in the examination. Okay. So if they are asking about the total wave, then you need to be good, you need to have good amount of concentration in the examination. And these kind of questions has never been asked till this date. But they are very good concept which I am expecting in future. So here we did not discuss any total internal reflection, nothing like that. Even if it was not the case of total internal reflection, still our answer would remain same. But now what we need, which point we need to prove? The point we need to prove is about the second medium. In second medium, what is happening? Because as per our understanding, if the wave is incident at a critical angle or greater than critical angle, that means there is a case of total internal reflection. And if total internal reflection is there, that means there should be no wave in the medium 2. So let's check out if there is any wave in the medium 2 or not. For that, what I need to write down? Let's remove it off. So for writing down the wave in medium 2, if I need to write down that transmitted wave, so which coefficient I would require? Transmission coefficient, right? So let's write down the value of transmission coefficient now. So what will be my transmission coefficient? So here I am writing down 1 plus gamma perpendicular is equals to tau perpendicular. Do you agree to this point? 1 plus gamma perpendicular is equals to tau perpendicular. So let's write down tau perpendicular. So tau perpendicular would be 1 plus e to the power j plus minus e to the power j plus minus 44.41. So can I write down in this manner? Cos 44.41 plus minus is also there. I should have made plus minus also there. But in cos, whether it is plus or minus, cos of theta is equals to cos theta. Cos of minus theta is also equals to cos theta only. Cos of minus theta is equals to cos theta as well. So if there is plus minus, that doesn't matter here. So that plus minus can be gone, or you can keep it. Plus j sin theta. J sin theta. What is theta here? Plus minus 44.41 degree. But in case of sin theta is equals to sin theta only. but sine of minus theta is equals to minus sine theta. So in case of sine, this minus sine will come outward. So what we are getting here eventually, this is my toe perpendicular. So my toe perpendicular will be 1 plus cos my toe perpendicular would be 1 plus cos 44.41 plus minus j sine 44.41 degree. So what you are getting, if you solve it, कहीं तो solve किया है, here it is. So when I solve it, I am getting 1.85 e to the power j plus minus 22.21. Fine. So this is what you are getting. 1.85 e to the power plus j 22.21 degree. So this is your reflection, this is your transmission coefficient. So now I need to write down my transmitted field. So let's write down the transmitted field. So ET. So your incident electric field will be multiplied with this factor, that is 1.85. E naught. It is having a amplitude of, sorry, it is having an angle of plus minus 22.21 as well, right? Then e to the power minus j, where the reflected wave is traveling. This is my reflected wave, right? If you see the diagram clearly, this is your reflected wave. This is your reflected wave. This, sorry, not reflected, really sorry. This is your transmitted wave. This is your transmitted wave. Transmitted wave is making an angle of theta t with z axis and 90 minus theta t with x axis. So this is what I am making here. So this is making an angle of theta t with z axis and 90 minus theta t with x axis. Theta t with z axis and this is with x axis, right? So can I write down here, can I write down in this manner? You let me know. Cos theta t z plus sin theta t x. Did you understand what did I do here? Look, how will I write down the amplitude? This is how I will write down the amplitude, because my incident field is E naught. So what will be my transmitted field? Because I know the transmission coefficient. So transmission coefficient is 1.85 e to the power minus j something. So that I have written 1.85. Now I need to write down the direction. What will be the direction of my E field? E field will be dancing in y direction only. There is no doubt about that. E field will be dancing in the same direction. Here also it was dancing in y direction. Here also it will dance in y direction only. But what about your wave? So here your wave was making an angle of theta I, but here the wave is making an angle of theta t. So this is what I have written here. Cos theta t j plus sin theta t x. Cos theta t with z direction and 90 minus theta t with x direction. So e to the power minus j k transmitted dot r cap. So what is your k transmitted? If you write down what is your k transmitted, what is this? This is your propagation vector for transmitted wave. Propagation vector for transmitted wave. What you are going to do? You are going to assume the magnitude to be 1. So cos theta t az cap plus sin theta t ax cap. And if I find out kt dot r, that would be cos theta t z plus sin theta t x, and that I have written here, right? Say yes or no. Just one sec. So this is my transmitted field. So if I write down the transmitted field, what I will get here? 1.85 E naught e to the power j plus minus 22.21 e to the power minus j. What is the value of cos theta t? We have found out, that is j. What is the value of cos theta t? Here we have found out, no? Cos theta t is plus minus j. So here this will be plus minus j z. 1 second. What I am doing is that this z is there as it is, cos theta t I am putting as plus minus j, plus what is your sin theta t? Under root 2 x ay cap. Basically, I have put the value of cos theta t, that is plus minus j, and my sin theta t was under root 2, right? Do you agree to this point? Very easily. What I am getting? 1.85 e naught e to the power j plus minus 22.21 e to the power minus j into plus minus j. So forget about plus minus sign. Minus j into j. J into j is j square. J square is minus 1. So what you are getting? 1 here. So plus minus j. So what you are getting here? Plus minus 1 z. Do you agree to this point or not? And beta, again I am forgetting beta here. Really sorry. Again and again I forget beta. So if I am writing kt, so here beta will also come, no? So again I forgot beta here. So beta is certainly there. Okay. Beta is certainly there. So beta, and then I am just multiplying minus j into plus minus j. So minus j into j is plus 1. Minus j into j is plus 1. So that plus 1 is there. So plus 1 I am not going to write. So here plus minus 1 would come. So plus minus beta j. Yeah, sorry for the interruption. So what I was writing, e to the power plus minus beta z, right? From here I go to e to the power minus plus minus beta z. And what about the x? E to the power minus j beta under root 2 x, and certainly it is in y direction. Did you understand what did I do here? This is just the amplitude, 1.85 e naught e to the power j plus minus 22.21 that you will get, e to the power minus j, and then what is the value of cos theta t? That is plus minus j that I put here, then sin theta t and root 2 I put here, and then from there I go to this expression. So what do you see here? What is this? This is an amplitude, this is an amplitude, this is just a phase. This is also an amplitude only. Amplitude which is decaying or increasing in z direction. And what is this? This shows the traveling wave nature. What I mean to say is that if my field was something like this, how? E naught e to the power minus alpha z cos omega t minus beta x plus pi by 3 ay cap. How will you write down the phasor form of this expression? You will write down in this manner: E naught e to the power minus alpha z e to the power minus j beta x. Here some quantity can also be there. That could be some e. So a e naught e to the power minus alpha z e to the power minus j beta x e to the power minus j beta x e to the power j pi by 3 ay cap. The same thing is written here. What about this? What you will call this wave as? This wave is traveling in x direction and decaying in z direction. The wave is the wave is traveling in x direction with amplitude decaying in z direction. This is what you will call it. Say yes or no, right? Same thing is happening here. What is this? This is just a phase. So forget about the phase. Here you can see that what this is showing. This is showing that traveling wave nature. Here you are having beta as well. Here you are having under root 2 as well, and x as well, e to the power minus j beta under root 2 x well. What does it mean? It is showing that traveling wave nature. So wave is traveling in x direction. Positive x direction. Now from here I have two opportunities. Either I will get plus beta z or minus beta z. Both cannot be there together, right? Either I will get plus beta z or I will get minus beta z. Now think about it, whether you will get plus beta z or minus beta z. Look, this is the equation that we derived. But in real life, can you get e to the power plus beta z? What does that mean? Here we are going towards infinity, right? So let's just say if I take e to the power beta z, that means at infinity it will have infinite amplitude. What does that mean is that the amplitude is increasing like this. Amplitude keeps on increasing. So is that possible? Your wave started from here and at infinity the amplitude is keep on increasing. No, this is not possible, right? The amplitude has to decay only, because if amplitude keeps on decreasing, that means you can make infinite EM wave energy. But you cannot make infinite EM wave energy. So certainly it has to be e to the power minus beta z. This I need to take. Are you getting this point? So that means we were taking cos theta t equals to plus minus j. For the whole analysis, we took cos theta t equals to plus minus j. We started from here, plus minus j, but actually it was minus j only. And where I go to know? I go to know here. Because if I take minus j here, e to the power minus j beta minus jz, then what I will get? Minus j into j will be plus 1 and another minus sign would be there. So this would be equals to e to the power minus beta z. So actually it was minus j only. This was actually minus j. Are you getting this point? Right? So this is a wave. Here what you are getting? Here you are getting a traveling wave which is traveling in x direction with decaying amplitude in z direction. And now if I make the field in medium 2, this was my medium 1, this is my medium 2. So if I make the field in medium 2, so here I will have the maximum field at z equals to 0. This is my z equals to 0 and I am going towards z equals to infinity. So here the magnitude will be maximum and slowly it would be decaying. And now this magnitude of wave will be traveling in x direction. This will be my field in medium 2. So what did we study? We studied that when there is a case of total internal reflection, there is no transmitted wave in medium 2. But that phenomena is wrong now. That phenomena was okay till higher secondary classes. But actually, if your wave is incident at a critical angle or more than that, that means if there is a case of total internal reflection, then still there will be some transmitted wave. And that transmitted wave will be walking in x direction with decaying amplitude in z direction. Is that okay for you or not? Are you getting this point? So this is how these kind of questions can be asked in statement wise, and certainly these kind of questions can be asked in your interview. And here I can see that I haven't connected my mic. So now I am connecting it. Sound will be better. How the sound will be? Sound would have been like for last 5 minutes the sound would not have been that good. But yeah, what we were focusing on? We were focusing on this part, that we need to find out the transmitted electric field, or I need to write down that transmitted wave equation. From there I go to know that my wave is traveling in x direction with decaying amplitude in z direction. I couldn't get the intuition behind it. Like I am not able, like for the incident and reflected wave, for the incident wave and reflected wave, I gave you the intuition that what is happening. Now why this is happening, I couldn't get the intuition, but using the equation we can certainly see it. Using the equation we can see that wave is traveling in plus x direction with decaying, plus x is upward, sorry, plus x is upward, I am showing like this. Wave is traveling in plus x direction with decaying amplitude in z direction. So slowly the amplitude will be completely decayed. What I am saying, slowly the amplitude will be completely decayed, because if z is too large, that means amplitude will be completely decayed. That means there will be no wave. The wave is traveling in x direction. Like if this component becomes 0, then what will be your ET? 0 only. Are you getting this point? If this component becomes 0, then what will be your ET? That would be 0 only, no? That means there is no traveling wave actually. But until this e to the power minus beta z, until this e to the power minus beta z is there, till that point certainly there is a wave. So in the statement wise question, if I ask you one question, that in case of total internal reflection, there is no wave in medium 2, absolutely wrong. Second statement, in case of total internal reflection, my wave would be decaying in a particular direction and traveling in a particular direction. Yes. In case of not total internal reflection, in case of any ordinary reflection, in medium 1, you will have a combination of standing wave and a traveling wave. And standing wave will be in z direction and traveling wave will be in x direction. But that depends how your, this will depend how your incident wave is coming. Like if the incident wave would have come like this, then the direction would have changed. But incident wave is coming like this, then direction would be something else. So that depends on your orientation. But the conclusion is, this side standing wave and traveling wave, standing wave like this and traveling wave going upward, and this side there is a decaying wave and that is going upward. Are you able to visualize it? Are you able to see it? Right? So these kind of questions can come. Now another question, this is a traveling wave, no? This is a traveling wave. What is the velocity of this traveling wave? What is the velocity of this traveling wave? So if someone asks you, like if you are blindly solving this problem, here if I ask you what is the velocity of traveling wave here, what you will say? That sir, it is equals to c only. Vp is equals to c upon under root epsilon r. So that is equals to c. But that is only correct for ordinary reflection case. If there is a case of total internal reflection, that means the wave will be different here. What people will be thinking that, okay, there is total internal reflection, that means there is no wave, so velocity is 0. That answer is also wrong. If someone is blindly solving it without even thinking that there is total internal reflection, then he will say that it is equal to c. This is also wrong. What is the actual traveling wave velocity? I need the answer from your side. You need to write down just now. If you are watching this video, if you are watching this brilliant concept, then just write down in the comment section that you are finding it pretty good and what will be the velocity of a traveling wave in medium 2. That answer I need from your side. So just pause the video and write down the answer. Here you are having the expression as well. I guess you all will be able to write down the answer. So what will be the answer? So first I need to find out what will be my velocity of EM wave in medium 2. So for that, Vp equals to omega upon beta x, right? What I will write, Vp upon omega, so Vp equals to omega upon beta x, beta 2x actually, beta of medium 2 x. What is the beta of medium 2? Beta of medium 2 is omega by c under root epsilon r. What is the value of omega given? 3 into 10 to the power 8. What is the value of c? 3 into 10 to the power 8. What is the epsilon r here? 1. So beta 2 is set as 1 only. I have set the value of beta in a manner that it is 1 only. So here what I will write? 1? No. I need to see the component in x. So this was my wave. This was my wave. It was making an angle of theta with the z axis and it was making an angle of theta, 90 minus theta t with x axis, and this is making an angle of theta t with z axis. This is your z, this is your x. Where my wave is traveling? My wave is traveling wave in x direction. So which component I will take? If this is my complete beta, so only if I write down beta x, so that would be beta cos 90 minus theta t. Is that clear to you? So that would be beta sin theta t, and that is your beta into under root 2. This I am calling as beta 2. So here beta 2, beta 2, beta 2. So beta into under root 2. So that would be equals to under root 2. So here what will be the answer? 3 into 10 to the power 8 divided by under root 2 meter per second. Tell me, isn't it the brilliant concept? Say yes or no, right? So what is the total field? How the total field will look like? This is how the total field will look like, and both will be traveling in x direction. Both will be traveling in x direction. This is how the total field will look like. Here standing wave pattern, here decaying field, here decaying field. Although the field is like this here the field is decaying like this, decaying field, and that decaying field is traveling in x direction. What is the velocity? Traveling wave, here decaying wave, and here standing wave, right? Standing wave. And if I write down the velocity of that traveling wave, what that would be? Omega upon beta x. And here also it would be, this is medium 1, this was my medium 1, this is my medium 2. So for it would be beta omega upon beta x. And how can I find beta x? Certainly I can find beta x as well. This is my incident field. This is making an angle of theta t with z axis and 90 minus theta with y axis. So this angle was theta I. This was my beta 1, and this would be 90 minus theta I. So what will be my beta x? So my beta x would be total beta 1 into sin theta I, because what is cos 90 minus theta I? That is sin theta I. So this is my beta x. And what is my beta 1? Beta 1 is omega by c under root epsilon r1, right? So here I am writing beta 1 as well. So my beta 1 is omega by c under root epsilon r1. So this is just the summary of whole discussion that we have done. And what about this thing? Here what will be your, so this will be your wave. It is having two component. If this is my complete beta, if this is my complete beta 2, this is making theta t angle, this is making 90 minus theta t angle. So actually I need to take the component of x direction only. So what will be my component of x direction? That would be beta 2 sine theta t, right? And what is your beta 2 here? Beta 2 is omega by c under root epsilon r2. There you go. This is the complete summary of the discussion that we have done till now. Say yes or no. So this phenomena will be achieved only in case of total internal reflection. But this phenomena will be achieved whether it is total internal reflection or ordinary kind of reflection. Are you able to understand this point or not? So let's write down another summary now. Another summary we are going to write down. So what we are seeing here, that this is my incident wave, this is my reflected wave, this is theta I, this is theta r, this is theta t, and this is the transmitted wave. Medium 1 is there, medium 2 is there. This would be having something epsilon r, this is having something another epsilon r. Now this axis I am calling as L, this is M, and the axis that is coming towards me, that is your N. This is how I am telling. Now I will write down where and where I will get what kind of waves. Okay. So now we saw this case only for perpendicular polarization, right? We saw this case for perpendicular polarization, right? Here we saw it for perpendicular polarization, and that too also for which kind of condition? For total internal reflection. We saw this case for total internal reflection, but only for perpendicular polarization. But that is same for parallel polarization as well. You can check out. You can take any random example and check out for parallel polarization as well. That is the same case. So you can check it for parallel polarization as well. Well and good. Okay. So for both perpendicular and parallel polarization, this concept is applicable. In case of normal reflection, here I should have written ordinary reflection. So in case of ordinary reflection, so total wave in medium 1, what will happen? Incident wave is there, reflected wave is there. So this component here, both combined traveling wave. This component here, both opposite standing wave. So standing wave in which direction standing wave? Standing wave in M direction. Because what is this axis? This is L. What is this axis? This is M. So you can see here M and this M opposite. So standing wave in M direction and traveling wave in L direction. Standing wave in M direction and traveling wave in X direction. Total wave in medium 2. This is ordinary kind of reflection that we have previously studied. Which kind of reflection we have previously studied? There was no case of total internal reflection. Here our cos theta t was somewhere between -1 to 1 only. So at that time what will happen? In medium 2 you will get the traveling wave only. So traveling wave only you will get. Like this will be a simple wave. Simple traveling wave which is traveling in ML direction. So traveling wave in ML direction. If I ask you the VP of this one, so what will be the VP of this one? That you can write down, right? That would be omega upon beta. Where is the traveling wave? Traveling wave is in not X, sorry. Really sorry. This is L, right? Here it is L. Beta L. And beta L, can you find out? Yes. What is your beta L? Beta L is beta 1 cos, not cos, sin theta I. But you don't need to mug up all this formula. If you are mugging up, then there is no point of this much discussion. There is no point of effort from my side. There is no point of effort from your side. You have all the things clear in your mind that where it is traveling, why I need to take the X component. Here I have seen no, why I need to take the X component and how will I take the X component. That also is clear to you. So no need to mug up all these things. So here I'm not going to write down all these things because here we have already written. And if I write down all these things here, then you will just mug it up. So let's not write it down. But here in this case, what will be the velocity in this case? That will be simply Vp upon omega beta 2, right? For medium 2, I am saying that I am having beta 2 and for this one I am having beta 1. So that will be omega upon beta 2 because this is the normal wave. This is the case of ordinary reflection. This is not total internal reflection. Not total internal reflection. So this is the simple wave. Vp upon omega, Vp equals to omega upon beta 2. That formula we need to apply. This is a simple wave. But in case of total internal reflection, what happens? This remains same. That standing wave in M direction and traveling wave in L direction. this remains same. But what about this one, traveling wave? This doesn't become traveling wave. Traveling wave will be there in M direction. Sorry, no. Traveling wave will be there in L direction. Traveling wave in L direction with decaying amplitude. With decaying amplitude in M direction. Say yes or no. I hope you are able to connect the dots, right? Now for normal incidence, what was the case? For normal incidence, if you remember the case for normal incidence. So standing wave in medium 1 and traveling wave in medium 2, because in this was the incident wave, this was the reflected wave, and this was the transmitted wave. So transmitted wave was the normal wave. In case of medium 1, what was happening is that incident and reflected combined was making standing wave. So standing wave in medium 1, standing wave in medium 1 and traveling wave in medium 2. Okay, so this is a very good concept that we have seen. We have seen the total internal reflections using wave phenomena. We have seen where do we get standing wave, where do we get traveling wave. So now you will be very comfortable in these kind of analysis if this kind of question is coming, because till now if they have framed any question on oblique incidence, they have framed it very straightforward. But now if you have done this kind of analysis, then you would be very comfortable with any kind of question if they are asking, whether it is based on total internal reflection, if they are asking the velocity, if they are asking any single thing. Say yes or no. Okay, so I was thinking to end this like complete EMFT in this video only, but let's take to the next video. In the next video, what we are going to study? We are going to study the polarization at media interface. So what kind of questions we need to see? We will see that if the incident wave is circularly polarized, then how will the reflected wave will look like? How will the transmitted wave will look like? Whether it will be circularly polarized or elliptically polarized, or it will be linearly polarized. So these kind of concept we are going to see. So let's make a separate video on that, because both are total different concept. But here certainly I will take the concept of total internal reflection as well. Okay, certainly we will introduce total internal reflection as well here as well. Okay, so certainly your concept of total internal reflection will also be used, but in the next video. Thank you very much, and I hope you enjoyed it. If you have enjoyed it, I would expect your comments, because I know this kind of concept is not usually taught anywhere, right? So yeah, thank you very much.